Hi everyone, I hope your Christmas break was good and everyone stayed safe and healthy. Today's lesson is going to be on Introduction to Slope, which is all about what we're going to be learning in this unit. You guys probably remember slope from 8th grade. You probably did a little bit with it, but we're just going to do some more with it. But before we actually talk about slope, we need to look at graphs and see how things move and see what each thing means, if it goes up, if it goes down, certain things like that. Okay, so that's what our lesson is going to be on today. But when we start getting into slope, there are two types of functions that we like to talk about. One is linear and one is nonlinear. So what you're going to do is you're going to take notes as I go along while you're watching. So a linear function is a straight line. Okay, there is more to know about linear functions, but we will get to know that a little later. I don't want to confuse you and throw too much information at you all at once. So the only thing you need to know for today is a linear function is a straight line, while a nonlinear function is not a straight line. Okay, so anything that has a curve to it, any other shape that's not a straight line. Okay. Now, so that's really the only thing you need to know about linear and nonlinear functions for today. Okay. So if I were to be in school, we were going to do this activity that we used a motion graph, something called a CBR, which is like a sensor that we would use so we can start looking at distance time functions. Okay. And when we talk about slope, distance time functions are super important. Okay, so with these 4 bullets here, you're going to write as I go along. So when we start to create something on a distance time graph, we have to ask 4 questions to ourselves, okay? And that's what we're going to write on these 4 bullet points, okay? So the first question is, where does the object start? Or where the object starts. So that's the first thing we're going to ask ourselves. Does it start closer to the sensor? Does it start farther away from the sensor? Does it start 1 meter from the sensor? Whatever that may be, okay? And in most cases, we will tell you what that is, okay? Then we're going to ask ourselves, what direction does it move in? Okay? Is it moving closer to the sensor? Is it moving farther away from the sensor? Okay, in today's case, we're going to use sensor. In other cases later on, it may not be a sensor. It may be a certain object like my classroom or like, I don't know, the football field. Okay. Third question we're going to ask is, how fast is it moving? Okay. Are we walking slow? Are we running fast? Are we jogging at a slow pace? Are we just walking at the same speed? Okay, so those are the different options. And then the last question you're going to ask is it speeding up? So is the object we're talking about speeding up, slowing down, or is it moving at a steady pace? Steady pace or rate. Okay, which just means, are we staying the same? Are we walking, or is the object moving at the same same rate the whole time, or the same speed the whole time? Okay, so these are the 4 questions we're going to ask ourselves every time we do this. Where does the object start? What direction does it move in? How fast is it moving? Okay. Now, if I were to be in school and we were doing this in school, okay, we would actually be getting up in the classroom and walking from a sensor that would help us graph these things. But because I'm not in school, okay, we are just going to do it as I talk through it. I think you guys will understand the same. It would have been more fun, but there's nothing we can do. Okay, so I'm going to do 1A and B with you, and actually C and D, and then we'll talk about the back. Okay, so the first question is 1A. We're going to read it. Okay, stand 1 meter from the sensor. Walk at a constant, steady, slow pace away from the sensor. So the first thing I'm going to do is ask myself question 1 that was up here. Where did the object start? And this told me it started 1 meter from the sensor. Okay, so on your distance time graphs, you could see that it's labeled. This is your distance and this is your time. Okay, so we said that the object, where is the object starting? And this said stands 1 meter away from the sensor. So in this case, you would be the object. So you are standing 1 meter away from the sensor. And remember, we are talking about distance here. Okay, so I'm going to put a dot at 1 meter because that's where it starts. Okay, then it asks myself, where does it move? So the next question, I'll start in red and then I'll highlight it in red. Where is it moving? And in this case, it's moving away from the sensor. Okay? So now I'm not going to draw anything yet because I need to know how fast it's moving before I can draw something. So the next question is, how fast is it moving? Okay? And here, I will do it in yellow. Okay, and I'm going to highlight how fast it's moving, and it's moving at a slow pace. Okay, so this is all the important information that we need. And then the last question I would be asking myself is it speeding up, slowing down, or moving at a steady rate? Okay, and I'm going to highlight the word steady here. Okay, so we have all the information we need. We know that the object started 1 meter away from the graph. So I'm going to put it at 1. I'm going to put my dot at 1, okay, which I already did. So I'm just going to color over it again. Now, I know that this line, or my object, was moving away from the sensor, okay? So as we get farther away from the sensor, we have to move up, right? Because this is where my sensor is at 0, 0 every single time. Your sensor is the distance is 0, 0. So if it's moving away, right, the graph has to go up if it's moving away. Okay? And in this case, we are moving at a slow, steady pace. So what this would look like, remember, steady, and all steady means is just a straight kind of constant line. So I am moving at a slower, steady rate. So this is what the graph would look like if we were to be doing this in school. But you can do it without the sensor actually being in front of you. You just have to think of it, okay? So let's do the next one. So we are standing 1 meter away from the sensor. That's important. So I'm going to highlight it. 1 meter away from the sensor. That starts with my first question. So I can go ahead and put a dot at 1 meter away from the sensor. Okay. Now I am walking away from the sensor. So I'm going to highlight that. Okay. And my other piece of information is I am changing my pace from slow to fast, okay? So if we are moving slow to fast, I'm going to show you what this looks like. So if we are moving slow, remember, over time, we're not really getting very far. So if I were to draw this line, over time, I'm starting off slow, right? So I'm not getting very far. I'm not getting very far. But then I start to maybe jog or sprint. So my speed, as time goes on, my distance would increase much quicker. Okay, so this is what the graph would look like if we were walking and then decided to sprint. Okay, because as time goes on, at first we were moving slow, so we weren't getting very far from the sensor. But then when you started to sprint, our distance went very quick over just 2 seconds. Okay, so remember, again, this is your sensor here. All right. All right, let's look at C. So, once again, let's highlight some information. I am standing 1 meter from the sensor. Okay, remember, this is your sensor. Okay, and if I'm 1 meter from the sensor, I know that I'm starting here. Okay, and again, I am walking away from the sensor. So anytime I walk away from the sensor, your line will go up. Okay, your graph will be moving up. Okay, and then in this example, my pace is going from fast to slow. So in the last one, we went slow to fast. Now we're going to move fast to slow. Okay, so for the first couple seconds, I'm running. I'm moving very fast. So I see a very sharp increase. Okay, because I'm moving quick over a short span of time. But then I get out of breath, so I'm like, I'm just going to walk now. Now, I am still moving away from the sensor, so my distance is still going up, but just over time, it's only increasing very shortly, right? It's just increasing at a slower rate. So if I were to graph what this looks like, that would be it. Okay? Now, D is looking a little bit different. So I am standing 5 meters away from the sensor. So this is new to us. Over the past couple examples, we were just moving, we were standing 1 meter away, but now we're standing 5 meters from the sensor. So all this means that instead of putting a dot at 1, we are now going to put a dot at 5, because this is where our object starts. And remember, that's on your y-axis, because we're talking about distance here, 5 meters away from the sensor. Okay? What's also different here now is rather than walking away from the sensor, we are walking toward the sensor. So when we walk toward the sensor, so you should be writing these little notes down too on the bottom of your paper, the graph is going to go down, right? Because we need to get here. This baseline, this x-axis, the base of that is where your sensor is. So you want to go toward that. If we're moving toward the sensor, the graph will have to go down, okay? And here it says we are just walking at a constant rate. Oop. We are walking, at a constant rate, okay? So what this would look like is if I'm just walking at a constant rate, okay? Remember, I have to go down. My graph has to go down because I'm walking toward the sensor. I want to get to here. This is my sensor. So over time, I'm walking toward the sensor at a constant rate. So my line would just be a straight diagonal line, okay? Here it doesn't tell us if we're walking fast, slow. It just says it's a constant rate, okay? So go ahead and flip to the back page, okay? And what I would like you to do is try these out, okay? Try the ones on your back page out. So pause this video, okay? Try them out, and then when you're done doing those 4, you can come back, and I'm gonna we're gonna talk over it. Okay, so go ahead and pause, and then when you're ready, you can press play. All right, so now that you've done these 4 on your own, we're gonna go over the answers. Okay. If you didn't do these 4, please stop and do them on your own, okay? I will not be here when you practice, so you need to be able to know how to do this on your own without me just going over them, okay? So we should have done the same type of thing, okay? So this first one says we are standing 5 meters from the sensor, okay? And once again, we are walking towards the center. That's important information, which means our graph will be going downward, okay? And this example says we are starting slow, and then we are speeding up, okay? So we know that we're starting at a slower pace, walking towards the sensor. So I'm moving slow, but then all of a sudden I start to run. I'm in a rush, so I have to sprint towards the sensor, okay? So as you can see, over the first 3 seconds, we only got 1 meter. But over the last 2 seconds, we got 4 meters, okay? All right, now F says stand 5 meters from the sensor. So once again, we are standing 5 meters from the sensor. And we are walking toward the sensor. So once again, means my graph is going down because I have to get to the bottom, to the x-axis where my sensor was, okay? Now, this is just the opposite, okay? At first, we're moving quickly, and then we begin to slow down, okay? So what this would look like is in the beginning, in maybe 2 seconds, we get 3 meters. And then we get out of breath, so we begin to just move very slowly towards the meter. Okay? All right, now, I don't know why this copied weird, but G is here and H is over there. Okay? So we're going to look at just G. So we are standing 1 meter from the sensor. So back to 1 meter, I'm going to put my dot. Okay? And this just says we are standing still the whole entire time. We're not moving. We're not speeding up. We're just standing there. Okay? So over time, I'm going to ask you this question. You can answer it in your head. Over a time of 5 seconds, if we are just standing still, is my distance from the sensor going anywhere? Is it going away from the sensor? Is it coming towards the sensor? Or if I'm just standing still, does it just stay still? Okay, so as you think that over, remember, if you're standing still the whole time, you're not moving. Okay, you're not getting closer to the sensor. You're not getting farther away from the sensor. You're just standing still. So what this graph would look like is just a straight horizontal line at 1 meter. Okay, that's all. Because you're not moving. Your distance is not going anywhere. It stays the same the whole entire time. Okay? All right, now, this last one here, I don't really know why it copied like this, but this is for this graph over here. Okay? So, we're going to read this together. Stand 1 meter away from the sensor. So, drawing my dot at 1 meter. Okay? And I am standing still for 3 seconds. Now, this is just what we talked about on the last problem, right? If we're standing still, our distance is not increasing nor decreasing. But what's important here is this 3 seconds, right? I am standing still for 3 seconds. So I drew a straight line at 1 meter all the way up until 3 seconds. Okay? And then it said we then walked away from the sensor at a constant rate. And remember, if we walk away, my graph goes up, okay? And if it's just a constant speed, we're not really going fast or slow. We're just walking at our normal rate, okay? So just a normal diagonal line, okay? So if we were to actually be walking and doing this in class, you would get to see them through the sensor that we have, but it's just as easy to talk about it, okay? So now what you're going to do is, once again, pause this line and try and answer these questions for me. Just try and fill in the blanks. Okay, so pause, take about 2 minutes, and then press play again, and I will go over it with you. Now, please do this in pencil, so if you have to erase your answers that you guessed or that you filled in the blank and they're wrong, just go ahead and erase them and correct them with what I will write. So pause this video now, try and answer them on your own, and we will go from there. Okay, so in 2 minutes, go ahead and press play, and you will get the answers. All right, so now that you're back, okay, we're going to talk over these fill in the blanks, okay? This is based on what we were just doing. So, if the motion graph was a straight line, now I don't mean a horizontal line or a vertical line. I just mean like a straight line as in so. Just a straight diagonal line. Then our walker's speed must have been what? And we know that if it's just moving at a straight line, a straight diagonal line, then the walker's speed was constant or steady, whichever way you would like to write that. Okay, so it was either constant or steady. So, a steep line, so if it was something like this, a steep line is caused by a person doing what? So remember, over time, it increased very quickly. So our walker must have been moving fast. Okay? Now, a decreasing line, so any decreasing line, whether it's, slow, steep, steady, okay, no matter what, if our line was decreasing, okay, this means that we were walking toward the sensor, right? We talked about this. Anytime our graph is decreasing, we are walking toward the sensor because we want to get closer to where the sensor is. All right, the next one, I don't know why I don't have it on here, but I think the next one says, oh no, I have it. The next one is a horizontal line is caused by a person who what? Now, we talked about it. It would look something, so a horizontal line, which means we are never going up or down. So my distance from the sensor is never moving, right? This would be a case of the person or the object is just standing still. So that's what you're going to fill in the line. Okay. Then we have E, which says an increasing line is caused by a person walking. So in this example, it may be a steep increasing line, or a steady increasing line, or a slow increasing line. Okay? Anytime a graph or a line is increasing, this just means that we are walking away from the sensor, or an object is moving away from something. Okay? And then F. I don't know, I don't have it on my screen, but you guys have it on your paper. And it says something like a vertical line is caused by what? Caused by a person who... Now, if you didn't get this one, that's okay, because there was no examples like this in your practice for the day, but it's important because in this case, this is not possible, okay? This is something that is impossible. You can never have a vertical line on a distance motion graph or something like we were working with today, because this would mean that a vertical line is caused by a person who stops time, okay? And we all know that nobody could stop time, right? If we had a vertical line, it would mean that our distance is growing, but time is not, okay? And we all know that time is always moving. So you're going to write stops time on your line, and then with a star, you're going to write impossible. Okay, and as we get more and more into our slope, you'll realize that vertical lines do not have a slope. Okay, we're not going to talk about that today, but anytime we have a vertical line, we will know that it has no slope. So you could write impossible, vertical line does not have a slope. Okay? And that is all for today's lesson, okay? If you have any questions, you can message me. We could set up a Zoom time for after school, and I would be more than happy to meet with you. But you just got to let me know, okay? I hope you're all doing well, and I miss you all.